hydrogen atom. It helps us derive what we should think of perturbation. So I'll discuss that quickly. And there may be some of that done in recitation. So we're going to discuss now the Dirac equation. So the Dirac equation begins with the observation that we have E squared minus P squared C squared for a free particle is M squared C to the fourth.
Again, in my personal vested interest in trying to gain an understanding of particle theory, gravitational pull, wavelength frequency, it's just in my best interest to just say, well, there's two, it's energy squared. So you could say there's two particles minus, well, you do photon squared, constant squared, subtracted from two other particles. Okay, so this can just be a division of particles in a particular field. I mean, this is what it is. It's calling this math. I mean, this isn't really math. This is algebra. This is calculus. It's not geometry. It's not math. Math is elementary. F equals ma isn't even elementary. So this is just beyond. I mean, this stuff isn't beyond anybody who has graduated high school. Everybody who has graduated high school can gain an understanding of evolution or something like this, but they look at it and they say, well, who did this? Like who perverted math? And it's just not the case. It just is. You can make it whatever. It is an interpretation. You can make it whatever you want it to be.
This dispersion relation that relates E and P for any particle. So if you wanted to describe the dynamics of a relativistic particle, you could say, look, the energy is the square root of P squared C squared plus M squared C to the fourth. Therefore, I should take the Hamiltonian to be that thing. I should take H to be that, and work with a Schrödinger equation that has this H with a square root. Nobody does that, of course, but you can.
I would say that is just completely reasonable. I mean, going along with what I'm saying in terms of quantum mechanics just being your own interpretation of it, or individualized interpretation, nothing really left to fact. Not to say that it's not a math derivative or it's a problem, just to say that it's not it's physics. And in terms of evolution, we aren't made for physics. We're made for engineering. We're made for construction. We're not made for this other byproduct, this theoretical, artistic, quantitative, quality of everything happening in the universe. It's just it's not philosophizing. But you can definitely, I'd say, gain your own philosophy of the understanding of quantum mechanics in a classroom sense, hopefully.
do a little bit with it, if you notice that this is equal to mc squared, square root of 1 plus p squared over m squared c squared, and then expand in small velocities where this is less than 1, you get 1 plus 1/2 p squared over m squared c squared minus 1/8 of this term squared, so p squared, p squared.
Again, so that's easily broken down, and you can say, or it's easily divided. It's easily just square rooting. Everything is just dividing just the particle or the atom smaller and smaller. And I would just say that having a vested interest in the opposition of thought, or thinking that thought going into the product of antimatter is the derivative of animosity towards quantum physics, and not being able to get out of classical mechanics because you're interpreting the thought mechanics or the psychological mechanics that go into just simply putting on paper, well, this is how I can break down a theoretical atom. The theoretical atom is can be broken down more, and this will produce more activity. And if activity in the universe is a constant, then I should probably come up with a way that to say that it's happening all over, and it's not just happening in a in a single force, in a single opposing force towards myself, for lack of a better phraseology. But that's just interpreting the reality of how expensive just going anywhere with the physical universe is actually going to be.
Over m to the fourth, c to the fourth. And then what do you get? mc squared plus 1/2 2m p squared. That's very nice. Apart from the rest energy, you get the p squared over 2m that you would expect. And the next correction is minus 1/8 p squared over m cubed c squared plus dot, dot, dot. You know, that's one way you could treat the Hamiltonian, but it's very complicated.
Again, just it's not complicated. It's an interpretation. Like, classroom settings don't need to be have prison walls. They just need to be educational. People need to be critically thinking about math equation that is trying to interpret the physical universe, trying to interpret natural reality. That's all this is doing. It doesn't need to be. People aren't critically thinking about this stuff. They don't have. Their parents are paying. Their parents are paying. Physics students' parents are definitely paying for their tuition. Everybody else in all the other subjects, yeah, they're most likely, they have student loans or something like that. But there's no people with student loans looking at these math problems and thinking critically about quantum mechanics. I'll tell you that much. My belief in millennials right now. I just don't think millennials are taking out student loans to try to become the next Einstein. So yeah, I mean, you just look at it and you say these things. A 1 in the universe is constant. A 0 in the simulation theory is a freeze. The gap is just another problem. It's just more polarization. It's just more magnetism, electricity. It doesn't make a difference. That's the elevation of the language, of the code of physics. It's really not imprisoning
Don't treat that Hamiltonian too seriously, because the Schrödinger equation would have infinite number of spatial derivatives, p to the 4, p to the 6, p to the 8. Never going to get that understood. But in terms of perturbation theory, we can think of p squared over 2m, your original Hamiltonian, and here is...
Yeah, in perturbation theory, you can create something like that. What is this? Anti-vector. And anti-vector is how I've heard it described, which I think is a pretty decent way to look at that. So you have a gravitational pull that is sinking the Earth, and then your anti-vector or your perturbation is the wave, sort of like the double slit above, like a double slit wave is sort of like a anti-vector. You could see it as something like that. And it doesn't matter which way, up or down, which way vertically which way on the vertical axis of Earth that those occurrences are happening, or whether or not they're happening in all certain places. It just matters that it's happening at a time rate while Earth is moving a distance, and light is being sent at a certain speed from the sun, and the moon is orbiting. That's all general relativity is. Just inquiring on the idea that Newton stating he didn't understand gravity as well as Einstein.
It's a relativistic correction that is small.
As if that was a meme.
But Dirac was puzzled.
I mean, it's almost one of the worst memes ever, like Newton and Einstein, like sitting at a bar talking about, like, how are these fools even trying to understand us right now, or why are they even calling us the two greatest minds ever? And all it really is a education racket, a racket on education.
By that square root. He basically looked at it, and I think he had sort of mathematical inspiration in him.
I don't think Darwin has any rolling in the grave animosity towards the human race. I think he's just petrified of, I think evolution is creeping in. It's taken a while, though. It's definitely taken a while. I mean, I'd like to see some people in Africa talking about evolution. I'm really tired of white folk and Europeans being the only people that are even allowed to talk about evolution, since evolution has so much racial divide or racial tension, or Darwin was a racist or something like that. Richard Dawkins is a brilliant, beautiful hierarchy of need, and then Darwin is like some child molesting bigot. He's not rolling in his grave. He's petrified of what Jesuits did in Africa. I would like to see some people talking about evolution out of Africa, not talking about the animals.
Here, he looked.
Oh, the babies. Oh, the animals. Comes to a certain point in time where there needs to be other inquiries of thought for a state or a country or a continent to change its role.
This equation, that square root, and I said, how much would I wish I could take that square root? What can I do to take that square root? So he said, well, I could take that square root. This has p squared, so c squared plus m squared c to the fourth. I could take that square root if that would be equal to something squared. which is not, because it's missing a cross product of the right amount. And
well, I mean, you're not going to get something like polarization squared. You're not going to get something the epsilon or the upsilon or the tau, like certain aspects in the universe that have an unequivocal constant that is describing dark matter, dark energy, or antimatter, or ether. These types of intuitions are they're just not set at an invaluable. They're very, you can move them all over the place and make up anything you want and turn it into a calculation. It just has to be interpreted. It doesn't have to be, it is just a different language. I'm not going to say people are doing pyramid schemes. It's just a tool.
it's not there. But if it would be there,
it's the I mean, unfortunately, it's the same as the artistic nature in classical mechanics. Just sharing equations is the same as sharing philosophical interpretation of the atom, or geometry of the atom, geometry of the nature of the universe, and then equations just doing the same thing. I'd say that's all it is. That's just the one divide that is keeping religion out.
the cross product, it would be a linear function of p and mc squared. So he said, okay, let me put a linear function of p. And
again, having a linear function, they're going to have to just create a nonlinear. They're going to have to just create some type of polarization. I think, as described, this is a classical mechanism. This is Dirac is a Newtonian mechanism. Dirac equations are Newtonian mechanisms, and I guess you could say particle theory, and they're just going to have to. They just have to create a gravitational constant, so to speak.
the most general linear function of p is obtained, I want a c squared, so c, by doing the dot product of a vector with p, a constant vector. A constant vector times p is the most general linear function of p. And here I'll put another constant, m c squared. And I hope I can take the square root, because there will exist such constants and it somehow will work. And you say, no, it cannot.
Again, the photon perturbation, p being photon or perturbation, in this case, the constant of the vector and the perturbation, it's easily interpreted. And just mass at a constant, you just have Earth. And in terms of this being the Schrodinger, again, because it's being squared, you could even have the square root of something like this and have a divisional attitude towards it, and it's just going to be, just turn it upside down.
Work, because there's always a cross product. But
add the moon orbiting, and it's done. Add the sun and its transition, and it's done. And those are another those are other variables. They're not testing a constant in the universe. I mean, you could test a constant in terms of trying to figure out what this perturbation is creating, but eventually, again, you just get into gravity again. and what is the moon or any type of star in your view? What type of effect is that having on the perturbation vector, the opposing, the vector anti-vector that is keeping Earth in perturbation with the solar system? Just looking for a gravitational constant.
Just follow this nose, and then alpha dot p, this is equal to C alpha 1 P1 plus C alpha 2 P2 plus C alpha 3 P3 plus beta MC squared. So let's...
Again, just the beta is going to be sort of a decompression effect on the Earth, and the alpha is just going to be talking about the wavelength, and you just add the wavelength, and you have more constants or perturbation and all that. All they do is just add time to it. All you do is just add the wave to it. It's not it's not philosophically redeeming, but it's perfectly logical. It's perfectly sensical in terms of an escape route from just some timeless story. There's an actual effect. I guess the effect isn't uncertain. The effect is very certain in terms of the quantum reality. In terms of the classical Newtonian physics, the uncertainty is what is a problem, just because quantum has psychology, so it's just, and all they are doing is just adding time, just adding the universal constant, and you add amplitudes and subtract, have a beta, have a beta variable, and some type of, just create some type of contraction in the force, and yeah, it's just, I don't see why it's not alluring.
Let's list all the things that should happen for this to work out. Well, the square includes the square of this, the square of this, the square of this, and the square of this, and those are what we want. So we should have that alpha 1 squared is equal to alpha 2 squared is equal to alpha 3 squared is equal to beta squared is equal to 1. If that happens, well, this term will give you C squared P 1 squared, C squared P 2 squared.
Again, this is also creating the wormholes and creating, what they just do, the wormholes or the entanglement or the multiverse. Alpha could be alpha could be the beginning, something like that. I don't really understand why. I don't take any of this stuff literally, but to say that there's another universe inside of a black hole could obviously just be saying that, just turning every anatomical constant into just turning it all onto the plane of the universe, turning just dissecting the universe as much as possible. Just say, well, oh, it's not the universe anymore. It's just a universe inside of a universe inside of a universe. Instead of just had to have constants to get another way to create a timeline in the human psyche, not to have, it's for no other purpose. That's all it is. It's just for history. People, it's a legacy effect. It's a photoelectric legacy effect, that we need to leave something that we need to leave something behind or have something to remember what we're here for. It's not this it's not a graphic of something that is that has a beginning or an end. In terms of well, just yeah, it's not a graphic of something that has a beginning or an end. It's something that is meant to be philosophically logical and sound, pretty.
C squared P3 squared and M squared C to the fourth, and I get everything to work. But the cross products must also work. So for example, the cross product of P1 with P2 should vanish. And that, well, if you write these two factors like that here, you would say, oh, what I need now is that alpha I times alpha j plus alpha j times alpha I should be 0 for all I different from j. So for example, alpha 1, alpha 2 plus alpha 2, alpha 1, when you do the product, should vanish. And I kept the order of these things there. It off by a factor of 2 that is associated to Thomas precession, but here it comes out directly with the right number. This is called spin orbit coupling, delta H of spin orbit. And there's one more term.
Again, just they can work with any part of kinetic energy that they want to. It's just an escape route.
Energy between things that have charges, electrons and protons. Work is a form of energy, so if you've had this photon means one electron making a transition. So that is equal to this constant, negative 2.18 times 10 to the minus 18th, and that's a joule, an energy unit. So the sign tells us if the electron's going uphill in energy, or in this case, downhill in energy. It's losing energy. Now, once we...
This whole idea of the balancing act and trying to throw light, like let's throw light at each other and measure it, and measure these ideas and put these ideas to work, and all of this showmanship at best. Yet it still is an improvement. It still is a development. It still is something that is just better, and just a better escape, and just to decide what is, how to create graphics of this and how to understand something like this. Yeah, that's fine. And have your wave and your velocity, your pi radius squared, square root, divided by constant squared times energy divided by energy. It really doesn't make a difference. You can say whatever you want, and the fact that people did this in an organized way is interesting enough. And so, I mean, if this is how they figured out quasi atoms, then this is how they figured out quasi atoms. It's not, doesn't have to be truth or fiction. It doesn't have to be true or false. It just has to be something that is adjusted, like it's just an adjustment on people's thinking, and that's all it is. And there'll be a way. I mean, people need a way to have to calculate. I mean, calculations are important, and the separation of Pythagoras and algebraic equations and understanding the interpretation timeline and escaping absolutes in geometrical forces of nature, of the universe, is a very, it's an important detour. It's not a negative. I would say the only thing it's adding a problem to is the geometry of the universe. It's not adding any other negative to anything. And for that, it has a purpose, or it's purposeful. It's useful. Again, typing in all these numbers.
Unit. So frequencies are huge, and that is how many times that wave oscillates. 6.6 10 to the minus 7. Transitions that fall to the first energy level are going to end up being in the ultraviolet part of the region. So the only transitions we're able to see, because our eyes only see the visible part of the spectrum,